Welcome to Video 2, Counting to Solve Problems. In Module 2, Meaningful Counting, you spent a lot of time focusing on 3 aspects of counting: stable order, one-to-one tagging, and cardinality. By emphasizing these rules that define how counting works, you have helped children get comfortable with the counting procedure. In this module, you will start by focusing on counting again, but with an emphasis on using it to solve problems. Most adults do not think of the question, "how many?" as a math problem. We commonly reserve that term specifically for situations in which we perform operations, such as adding or subtracting. But in fact, counting is the most basic solution approach to any problem that involves numbers. That is, whenever we need to know how many, counting is the first and most simple place to start. Young children need to see the counting procedure effectively used to solve problems repeatedly so they can generalize its usefulness. When they think, "I wonder how many," we want them to automatically follow that thought with, "Maybe I can count." There are many opportunities to solve problems with counting in the classroom. Perhaps you need to tell the kitchen staff how many children are here today. Counting can solve that problem for you. Maybe you need to gather enough carpet squares for Jordan, Kwaku, and Shonda to sit together in the reading corner. Counting the children and then counting the reading squares will produce the right amount. Children need to see that when things need to correspond, that is, when we need 1 piece of cake for each child and 1 scoop of ice cream for each piece of cake, counting is a way to find out what is needed and what is possible. It's important that you sometimes use these classroom-based problem-solving situations in a public way, announcing that there is a need to find out how many, sharing the idea that counting can be used, and then counting aloud or asking a child to count for you is an important process for children to see. That's why the first key instructional practice for this module is use counting to solve classroom-based problems and create opportunities for children to do so. When you ask who wants to use a jump rope at recess, then count out loud the hands raised by 4 children, announce that you need 4 jump ropes for 4 children, and then ask Sasha to count out 4 jump ropes from the basket. You provide a clear illustration of how this amazing procedure works. Children are highly motivated by the idea of there being enough of something, or the concept that things should be fair. You can use these interests to help children see how counting can help. Counting is not only useful when we need to make 2 sets correspond, it's also helpful to understand how set sizes change. That is, sometimes we know how many forks we have, and we know how many forks Tracy has. But what we need to know is whether we have enough forks altogether for 7 children. How many will we have if we put ours together with Tracy's? To adults, this sounds like an addition problem, but it's helpful to young children's learning for them to solve it using counting before moving on to addition. We call this strategy counting all. It's a form of directly modeling the plan we have of combining 2 sets, and it commonly goes like this. We count our forks. 1, 2, 3, 3 forks. Then we count Tracy's forks. 1, 2, 3, 4, 5. 5 forks. Then we literally put the 2 sets together, physically, creating a new set. We count the new set. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 forks altogether. Is 8 forks enough for 7 children to each have 1 fork? Counting the first 2 separate sets before combining them, a key part of counting all, may not seem like a necessary step, but it's very powerful for children's thinking. We want children to have some mental marker for the total amount of each of the sets before they are combined. And further, we eventually want them to know that 3 and 5 combined are always 8, so they can use this fact to solve problems when they don't have the first 2 sets available to them for counting. When we use the counting all strategy, by counting set A, counting set B, and then combining the sets and counting our new set C, we provide a clear model of how the addition process works. The counting all strategy can also be used when sets are separated rather than combined. That is, when you have 5 eggs and you need to use 2 to bake a cake today, you can use counting all to determine if you will still have enough for a 3-egg omelet tomorrow. The steps look different because counting all in this situation means you must first count the full set of 5, then count out 2 for your cake and separate them from the set, and then count the remaining 3 eggs to see how many are left. Just like counting all with addition, this direct modeling process helps children understand the mental steps behind subtraction problems. It's important to provide children with both combining and separating experiences. They need to generalize the idea that combining creates a larger set and separating creates a smaller set. This is yet another piece of information that is so obvious to adults that we often don't think to address it directly with children. Our students, however, need to notice how adding to and taking away change the size of a set, and talking with them about this is the best way to be sure they get the benefit of this experience. For this reason, the second key instructional practice of this module is prompt children to notice and discuss how the quantity of a set changes as objects are added and taken away. There are many classroom-based opportunities to help children notice how change affects set size. For example, when you count a set of markers and discover you need more in order for each child to have one, you can ask children, "What should we do?" This gives children a chance to think through the process of making a set larger. Once you have a plan for bringing more markers into your set, you can pause and say aloud, "So if we add markers to our set, it will get larger, right?" Then following through and making sure both the adding process and the resulting new amount are visible to children is like a great science experiment. Looking at the developmental progression for solving basic problems can help us understand the ages to expect some of these different strategies to appear. It can also provide information about the set sizes to use. Direct modeling strategies such as counting all are generally in place for amounts up to 10 around the ages of 4 or 5. Children are likely to continue to need to model all the parts of each addition and subtraction problem until the age of 5 or 6. At that point, they may be able to start using more advanced counting strategies. As you can see, using counting to solve real problems is an important step to helping children learn to think mathematically. By describing your problem or question and using counting to solve or answer it, you demonstrate the usefulness of the counting procedure. When you encourage children to use the counting all strategy to directly model the combination of 2 sets or the separation of a small set from a larger one, you help them build mental models of how addition and subtraction work. The activities in this module will help you find many opportunities to implement the first 2 key instructional practices. Use counting to solve classroom-based problems and create opportunities for children to do so. And prompt children to notice and discuss how the quantity of a set changes as objects are added and taken away.